This is worksheet 10.3 and we're looking at solving equations number 23 through 28. Looking at each of these equations, you have to decide what method to use, and there are more than one method to solve some of these problems. So use whichever method you feel most comfortable with. So on this first equation, I'm going to go ahead and write this with one side of the equation equal to 0. You can always check to see if a trinomial is factorable if you want to solve by factoring. This trinomial does happen to be factorable. The factors are x minus 9 and x plus 3. Solving for x, we get x equals 9 or x equals negative 3. On number 24, the goal here is going to be to try to isolate x. We can do that because we can add 2 to the other side, which gives us negative 1/4 x squared equals negative 4. And again, I'm trying to isolate x, so I'm going to try to get rid of this negative 1/4 by multiplying by negative 4 over 1. That gives us x squared equals 16. Square rooting both sides will allow us to isolate x, so that's x equals plus or minus 4. On number 25, I'm going to go ahead and set the equation equal to 0 first. And to simplify this equation, because the right side is equal to 0 and all of these are divisible by 2, I'm going to divide all of the terms by 2, including the right side. This does end up being factorable. We get x plus 2 times x plus 2. So we only have one root at x equals negative 2. On number 26, we need to try to isolate this expression here and then maybe treat it similar to how we treated 24, where we took the square root of the squared term. So in order to isolate this, I need to subtract 1 from both sides and also divide both sides by negative 1. Now that I have the squared term by itself, I'm going to square root both sides. This is being squared, so this side could be a plus or a minus 4. Subtracting 2, I have x equal to negative 2 plus or minus 4. So we have two answers, negative 2 plus 4, which is 2, negative 2 minus 4, which is negative 6. All right, on number 27, we have a square root in our equation. If we can isolate the square root, then we can try to get rid of the radical. So subtracting 3 from both sides, and then dividing by 1/2 or multiplying both sides by 2 over 1, we get square root of x equals 8. To get rid of a square root, to undo that, I need to square it, which means I have to square the other side. So x equals 8 squared, or 64. Our last equation here is an absolute value equation. If we were to isolate the absolute value bars by adding 5 to both sides, then we know that 2x plus 1 is either equal to 11 or equal to negative 11 because of the definition of absolute value. So 2x equals 10, x would be equal to 5, or 2x equals negative 12, which would give us a solution of x equals negative 6.